All right, so we're going to go over the 8.2 sample problems and the last lesson check question for 8.2, number 20 there. I just wanted to go through it as a video instead of just showing you the answers because, again, we're still learning the process. I just want to make sure that I describe what's going on, and hopefully if you've made a mistake, you can catch that in the description of how these are drawn instead of just looking at a picture and trying to figure out where you went wrong. Okay, so first off, question 7 asks you to draw chlorine, bromine, and iodine. Now remember from 7.1, anything that ends in I-N-E, ene, chlorine, bromine, iodine, fluorine, or gen, hydrogen, oxygen, nitrogen, those are all diatomic. And diatomic means two atoms. So chlorine isn't just Cl, it's Cl2. And so when you're drawing that structure, you have to draw Cl2, not Cl. So if you just drew Cl with 7 dots, that is not chlorine, that's a chlorine atom, but that would never exist by itself. And so we have to do chlorine as its pure form will always be Cl2. So Cl instead of just one chlorine, so two chlorines next to each other. That's the first step, is arrange your atoms. When you only have two atoms, they just go next to each other. You don't really have a middle atom, okay? Next step is give everybody 8 except for hydrogen, but we don't have hydrogen here, so we don't have to worry about that. So we put 8 dots around each chlorine. And there is your structure, okay? Third step is add, count, compare. Well, if you look at the periodic table, chlorine is in group 7A. So each chlorine has 7 valence electrons. 7 plus 7 is 14. There's 14 dots in the picture, so that is the correct structure. Bromine and iodine are both halogens as well. They are going to have 7. They're going to be exactly the same as this structure. Just replace the Cl's with Brs or with Is. Okay, number 8 had you draw 2 structures. One of them was H2O2, which is hydrogen peroxide. H2O2. As far as neediness goes, oxygen is needier than hydrogen because it's 2 away from being stable. It's got 6, it needs 8, it's 2 away, okay? Hydrogen's only 1 away from being stable because it's going to be stable when it's like helium and it only has 2 total, so it's just 1 away. Even though it's way on the other side of the periodic table, it's just 1 away, okay? So H2O2, oxygen's in the middle. There's 2 of them, so both oxygens are in the middle, and then I would put the hydrogens on either end. But you could put, one on the bottom of this one on the top of this one, or both on the bottom, both on the top. Just make sure that you've got both oxygens in the middle, and the hydrogens are on the outside as far as they are evenly distributed between those oxygens. Don't make one oxygen in the middle of all 3. Make both oxygens in the middle, evenly distribute what's left, okay? Then we give everybody 8 except hydrogen. Don't give hydrogen 8, you're going to mess yourself up. And then we add, count, and compare. So hydrogen has 1, oxygen has 6, oxygen has 6, hydrogen has 1. All together, that's 14. And I have 2, 4, 6, 8, 10, 12, 14. So that structure is correct. It's done. All right. The next one from number 8 is PCl3. Again, we're going to try to make sure that we make it really obvious when it's capital C, capital I, instead of capital C, lowercase l. When in doubt, it's probably chlorine, but you can always ask your teacher to see what it is. But phosphorus trichloride is what we're working with here. Phosphorus is in the middle because it is the most needy. Then pick 3 sides and put your chlorines. It doesn't matter which 3 sides. I'm going to go like this and leave the top open. You could leave a side open. You could leave the bottom open. It's totally up to you. But one side is open, 3 sides have a chlorine, and then you give everybody 8. Remember, if you want to use dashes as your bonds, you can do that and just use dots for the outer pairs, those lone pairs. Just remember that each dash represents 2 dots, so 2 valence electrons being shared to make that dash, that bond, okay? So this is just another way that you could do it, or you could have dots for all of those. Then add, count, compare. Phosphorus has 5 Each chlorine has 3. Don't forget there's 3 chlorines though. When you're adding it up, you have to have, or sorry, each chlorine has 7, sorry. So you have to add up 7 plus 7 plus 7 to get all 3 chlorines into your math there. So 21 total from the chlorine. Altogether, that's 26. And then you can count in your picture 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So this is the correct structure for PCl3. All right, number 9, hydroxide. Hydroxide is a polyatomic ion, OH minus. OH minus. All right, this one only has 2 atoms, so they just go next to each other. It doesn't matter. There's no neediness required in terms of putting this structure together. So OH, give everybody 8 except for hydrogen. So give oxygen 8. All right. Now we're going to add, count, and compare. Now this is where that first difference comes in for polyatomic ions. Oxygen has 6. Hydrogen, when it's by itself, has 1. So 6 plus 1. But there's one more thing we have to add in. This charge, a negative charge, means that we have gained an electron. So this structure has an extra electron. So we need to add that in when we're adding it up. So 6 plus 1 is 8. My picture has 8. So we're almost done, but this is where the second difference comes in for polyatomic ions. When you have a polyatomic ion, we have to remember this came from the charge. We have to explain why this has 8 and not 7 by putting the charge in our structure. And the way we do that is we put brackets around the entire structure and then a negative charge on the outside, so OH minus. All right, 10 more polyatomic ions. We'll do one of them right here. SO4 2-. Okay, we've got sulfur, we've got 4 oxygens. First step is the neediest goes in the middle. Well, if you look at the periodic table, oxygen needs 2 more to be stable. Sulfur needs 2 more to be stable, so they're equally needy, okay? So then size comes into account. Sulfur is bigger than oxygen, so it has room to bond to 4 things. It's lower on the periodic table, so it's bigger, okay? Another hint could be there's only 1 sulfur, there's 4 oxygens, so sulfur is going to be our middle atom here. Okay, so there's my sulfur with 4 oxygens around it. And then we go ahead and give everybody 8. I'm going to use dashes on this one for the bonds. Again, don't use dashes for the extra pairs, but that gives sulfur 8. And then I need to go back through and add the 3 lone pairs to each oxygen in order to make sure that all of them have 8. Okay? So I know those dots might be hard to see in your video, but I put 6 dots around each oxygen as well as those dashes with oxygen and sulfur. Okay? Now add, count, and compare. Well, sulfur has 6, 4 oxygens, and each oxygen has 6 on its own, so 4 times 6 is 24. And don't forget the charge. A -2 charge means 2 electrons have been gained here. So we add 2 more. We get a total of 32 electrons is what we should have in our picture, okay? When we count, we get 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So this is the structure. The final step for an ion is to put that charge on the outside of some square brackets, and then we're done with that one. All right, the other one on number 10 is not quite so easy. CO3 2-. CO3 2-. So again, neediest in the middle. So start with that. 3 oxygens around the carbon. It doesn't matter which side you leave open. So if you want to tilt your structures to see if they look like mine, that's great. Okay. Give everybody 8. I'm going to go ahead and use dashes again for my bonds. Then fill up their empty sides with pairs of electrons so that everybody has 8. I don't have any hydrogen, so I don't have to worry about the except hydrogen part. And then add, count, compare. Okay? Carbon has 4. Each oxygen has 6. Again, remember, you're looking at the periodic table for that number, not at the structure, okay? So each oxygen brings 6 to the molecule because it's in group 6A. Each carbon is bringing 4 to the structure because carbon is in group 4A, okay? So 3 times 6 is 18. And that -2 charge again, add 2 more, and we get 24. Well, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I've got too many electrons. I'm only supposed to have 24, and I have 26. So we get to erase a pair, add a pair to share. Erase a pair, add a pair to share. Remember, when you erase 2 pairs, those pairs have to come from 2 different atoms, and those 2 atoms have to be attached to each other. So I cannot erase 2 pairs off of this oxygen. I also cannot erase a pair off of this oxygen and a pair off of this oxygen, or a pair off of this oxygen and a pair off of this oxygen. All of the oxygens are attached to carbon. None of them are attached to an oxygen. So I have to erase the pair off the top of the carbon. And then I have to choose which oxygen am I going to steal from. Okay, I erase one pair, I have to erase another pair before I can add a pair to share. Well, I'm going to choose the right one. Okay, and then add a pair to share. In this case, I'm doing dashes, so I'm going to add 1 dash in between those 2 to share. Okay, so that is now 24. All of the atoms still have 8, so they're all still stable. The final piece, again, is brackets and a charge. And then you might think that you're done, okay? If you think you're done, you got super close if you got this far. That's great. If you didn't get this far, it's okay. I hope you understand why it's this. But if this is where you stopped, we aren't quite done yet. Since I had a choice, I could have chosen this oxygen or this oxygen to steal from. There were 3 places that I could have ended up with that double bond. It doesn't matter which pair you erased from an oxygen, it matters which oxygen you erased from, okay? So a double bond on the right is a double bond on the right no matter where I erased the pair from. But a double bond on the bottom and a double bond on the left, those would be different places to put the double bond. And so because there are different places, we get to that point where we have what's called resonance. This has resonance. There are 3 options of where to put the double bond, so I need to draw all 3 options. Don't forget, put a double-headed arrow in between your structures when you do this. Okay, I'm going to go ahead and put my arrangement into the brackets. By the way, the most you will ever have to draw when there's resonance is 3. So this is the hardest we'll ever get on drawing structures, okay? Now, on this one, I had the double bond on the right. I could have done it on the bottom or the left, so I need to represent both of those. So I'm just going to go ahead and draw my bonds on these ones. And then I'm going to go back through and I'm going to add dots to show that they all have 8. So this one right now only has 2, so I need to go 4, 6, 8. This one has 2, 4, so I just need to go 6, 8. This one has 2, so 4, 6, 8. So I'm just filling up, making sure that everybody still has 8 in my pictures. Again, it doesn't matter which side of the oxygen is empty. It just matters which oxygen has that double bond. Now remember, in reality, the real structure is a combination of all 3 of these, okay? It is not a double bond and 2 single bonds, and we know that because double bonds are short, single bonds are long, okay? Triple bonds are even shorter, but they're different lengths. In a real carbonate ion, we know that all of those bond lengths are exactly the same, and they're somewhere between a single and a double, okay? So that is the proper way to represent carbonate. Again, the real structure is a combination of all 3 of these. All right, last one, number 20. Number 20, easier than carbonate. Part A was H2S, okay? Sulfur is the neediest. So this can be your H2S. You have sulfur in the middle, single bond with hydrogen, 2 lone pairs on your sulfur, and then you're done. That one adds up correctly. 8 is how many you should have. For part B, we get pH 3. Phosphorus is the neediest. put 3 hydrogens around it. Again, it does not matter what side those are on. And then phosphorus has that lone pair on the top. And again, this one adds up to having 8 as well, so this structure is done. And then part C, again, CLF, not CIF. If you did CIF, it would be a lot different than what I'm going to draw. But for carbon, or for chlorine and fluorine, it's just 2 atoms, so they just go right next to each other. We give them all 8. Because we don't have hydrogen, we don't have to worry about that. So this is your structure. It's just 2 atoms, totally surrounded by electrons. You should have 14 dots because 7 and 7 is 14, okay? If this is a struggle bus for you, please make sure that you come and talk to us, Zoom with us, email us, T-breading, AVARCA. Either of us can help anybody. Come see us before school, after school, at lunch is at least preferable, but come see us and we will help you with this. If you don't ask, we don't know that you need help, okay? So please let us know and we will see you in class.